Hi, this is Jessica Meyer, and I've created a Geogebra sketch to model transformations. We have 7 different functions that we can look at, and this sketch was made for you to use in your classroom. A teacher could do it up at the front for all the kids to see and walk through it with them, or you could share it with the students and have them work on their own. So if I were the teacher, I might just do a couple at the front of the room first and then have them do it. So you could choose any function to start with. I'm going to start simple with the linear parent function, and then it shows up on the screen. I hit next, and now we're just looking at that function. And we can use this slider here to drag to see how A transforms the function. So we can drag it along in the positive and negative direction. We could use arrows to move more slowly. If we want to reset it back to the parent function, we just click on the reset button. And then on a next, we can animate the function as A moves. And hopefully by seeing this, the student can figure out what A does to the function. We can stop it and reset it if we want. And then they go through a series of questions they can answer. How does A transform the function? What if A is negative? Well, if they don't remember, they can just click on this. Well, if it's negative, then it gets rotated, it has a negative slope. What if the absolute value of A is less than 1? Well, we can also see what that looks like. It becomes less steep, and it moves closer towards the x-axis. Okay, the same is true for if it's negative. What does A represent in A times f of x when the parent function is f of x equals x? So in this case, A is the slope. And hopefully they can tell that. And next we move on to B. So we can drag to see how B affects this function. And then similarly to A, they can animate B. And then even if they don't click on reset, when you click on a next, it's going to reset it for them. And then they go through the questions again. How does B transform the function? What if B is negative? And then we move on to C. Again, we can move the slider and see how C shifts the function. And then we can animate C as well. Reset it if we want, or we can just go back to use of arrowing our slider back and forth or dragging it. How does C transform the function? What if C is negative? And hopefully they can tell. If they forgot, they can look again that C shifts the function to the left and the right. If C is positive, it's moving to the right. If C is negative, it's moving to the left. And then we move on to D. And they can go through the same steps to explore what D does to the function. How does D transform the function? What if D is negative? So, as D is positive, it moves it up. Or in this case, we could also say it moves it to the left. When D is negative, it moves it down or to the right. And then we look at If we're taking the absolute value of x and plugging that in, what does that look like? So they can see the parent function on here the whole time, and then they can compare that to the transformation. How did the parent function change? Well, they can see that this part to the right of the y-axis, it didn't change because that's where x is already positive. So if we plug in an x and take its absolute value, nothing's going to change. But to the left of the y-axis, well, now that side changed because when you plug in a negative x and you take its absolute value, it's going to match what we get when we plug in a positive x. And hopefully they'll notice that this part is reflected over the y-axis. And then we also look at the absolute value of f of x, which is different, but for this function, the result is the same as taking the absolute value of x. And they can toggle between those two, have them both up, or just one at a time. How did the function change? What does it mean to take the absolute value of f of x? So this time we're taking the absolute value of the output. So you plug in an x, you can plug in -2, and the parent function would give us -2, but we're taking the absolute value of that output to get +2. So it's essentially reflecting this part over the x-axis, which results in the same thing for these two on this particular function. But they'll get to see it for the other functions as well, and hopefully notice that there's more to it. So that's the end of that function. Now we can click on Start Over to try a different one. You can go into the quadratic function. So again, we drag A, see what happens. We can move A. How does A transform the function? Well, we can stop it. Well, it looks like the parabola becomes skinnier as A gets larger, and it is reflected when A is negative. It becomes an upside down parabola. What if A is negative? It's an upside down parabola. What if the absolute value of A is less than 1? So we can move this. So when A is less than 1, or in between 0 and 1, it spreads the parabola out. It becomes wider. It moves towards the x-axis. And if it's negative, and in between 0 and -1, it is also wider, but it's flipped upside down as well. And then we can look at B. Hopefully they'll notice that in this case B and A aren't the same. They don't do the same thing as they did on the linear function. As B gets larger, this function gets skinnier at a faster rate than what A did because the B gets squared also. And in my classroom I'd probably go into that a little more. But this is a good introductory lesson to what these transformations do. And they can watch it move, animate it. How does B transform the function? So we just talked about that. What if B is negative? Oh, sorry. In this case, if B is negative, it does not flip it over like A did, because again you're squaring the B, so when you square it, it becomes positive. And then we look at C. You can see that C is moving the function to the left and the right. So we can move C, stop C, reset, and talk about what C does. What if C is negative? If it's negative, it moves to the left. If it's positive, it moves to the right. And then we look at D. We're going to talk about the vertex. Maybe they could come up with a formula for the vertex using D. How does D transform the function? What if D is negative? If it's negative, it moves down. If it's positive, it moves up. And then taking the absolute value of x does not change this function. How did the parent function change? What does it mean? Do you see any type of reflection? And then taking the absolute value of the entire function f of x also does not change here. And you can go through those explorations with them or have them write their answers down. Then we have the square root function, and I'll just try to go through these more quickly. Let's see what a does. We can animate a. Do the same with b. How does b transform the function? What if b is negative? Then we look at c. It's pretty cool. You could talk about how c actually affects the domain of the function. And then d, and we could talk about how d affects the range. And then taking the absolute value of x is going to reflect it over the y-axis. And taking the absolute value of f of x is not going to change this function. Okay, and then we look at 1 over x. You can slide a. Can move a. I like watching this one. And then talk about how a transforms the function. What if a is negative? What if the absolute value of a is less than 1? It gets closer to the origin. And if the absolute value is greater than 1, moves farther away from the origin. But the asymptotes don't change. I would talk about this with my students as well. We change b. And then we do c.